Hey everybody, this is Larry. This is what was it? Weekly Contest 462. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this contest, these problems, and everything in between. I'm always looking to my right, I'm just trying to find my notebook. Oh, look. I don't know if you can see it. There's a Leetcode sticker on it. But in any case, yeah, just finding my notebook and a pencil so I could get ready for, well, today's virtual contest. Yeah, am I ready? Let's go. I mean, it'll probably be fun, and yeah, let's go. Did I click buttons? Yep. Okay. Did I? Yeah. Okay. It's hard to tell sometimes. Okay. Let's go. Flip square submatrix vertically. What does that mean? You have all these variables. Okay. You're gonna. Okay. I mean, I see what they're trying to go for, but I'm trying to figure out what the thing means. The parameters. Okay. Order of its rows vertically. Okay, but what does that mean? What does the X, Y, and Z mean? X and Y row and the column index of the, okay, upper left, so this is 1, 0, and then the side, oh, it has to be a square. Okay. Yeah, I mean, yeah, do they? I mean, I know that they want us to probably sound like they want to do us in place. We could probably do it in place, but yeah, it's such an annoying problem to kind of be correct. Alright, I mean, I think we're okay. No, I mean, yeah, I mean, I think we're okay. I think, yeah, I want. I'm not gonna do it in place. Is my point. What? Oh, what? Wow, am I just forgetting Python syntax for? Okay. Wow, what am I doing? Man, maybe I should have warmed up on a problem or something. Okay, yeah, and then well, maybe new I, new j is equal to g of ij, and then maybe do it this way. Maybe it's a little bit cleaner. So the reason why I want to do it this way is so that I could kind of separate the logic, and then kind of iterate on this without worrying about things being super wrong. Okay, so then we have x. Well, xy is a little bit awkward. Let's just go to ij then. It's still awkward, but slightly less awkward. Xy is the upper corner, so that means that if x, or if I is between x and x plus k, I think this is strictly less than, right? Because okay, if k is 1, then it's, yeah, okay. And y, same for y. I mean, then yeah, then we do stuff. Otherwise, we just return ij, right? We don't change. Okay, but we do have to change. Then we just flip vertically. Then it's just j will be the same, right? Because that's just a column. So then the row would be okay. So the delta row from the x, I minus x is the delta x, and then that's just going to be, that's the delta from x plus k minus 1. So something like this, right? Maybe. I know it looks awkward, but yeah. Is this even right? I wish they just have some way to tell us, other than like I mean, because these are the examples, so it should be okay to kind of do that as well. Yolo submit. Hopefully no silly mistakes. Okay, good. Very easy to make mistakes, right, for that one. So I, have to be careful. Yeah. All right, let's go. Maximum k to sort a permutation. What does that mean? Okay, so you have a permutation. You want to swap where if and only if I and num sub j is, oh, it's a bitwise and. Okay. I mean, they could just use a symbol. I don't know why they use like, yeah. Or they could use like a function. I don't know. This is a very weird thing. I mean, I get it, but it takes it. Anyway, okay. Stop complaining, Larry, and focus on bar. Return the maximum k such that you can sort non-decreasing using any number of swaps. Maximum, now you, okay. What does that mean? If we sort 1, then What is k again? Oh, only if the, okay. That's interesting. 1 means that right? It has to be pairwise, right? What is n? N is 10 to the 5th, so it is pretty big. It's not, so there's no like brute force thing, or it's not too brute force. Okay, that means that we want to swap these two. Okay, so I mean, I guess there's this idea of permutation cycles, but it's still. Oh, but it's max, right? So then permutation cycles, what does that look like? I mean, well, given a permutation cycle, there's only 2 ways to do it. Wait, is that true though? I mean, permutation cycle gives us the minimum number of ways to rearrange, but it doesn't mean that that's the only way, right? For example, you have just one number that's just swap. Can we just use one number and use it as a temporary variable? So that means it has to be one of the numbers, maybe. So 0, 1, and then here we could use 2 as the temporary variable, and everything and the 2 would be a 2, unless all the numbers are smaller than it. So that means that we have to look at all the numbers that are out of place. We don't want to use numbers that are in place, necessarily. Maybe. Returning 0 of the always sorted is actually kind of counterintuitive, but I have to remember it if sorted. I just return 0. I don't know. I don't want to think about it later and then forget it. I tend to forget a lot about these things. Okay, but otherwise, because 0 meaning all the numbers are swapped or sorted, and it is impossible to sort. Is kind of weird, but okay. So for every number that's out of place, it's definitely a weird one. Do we want to consider? Well, if a number is out, if a number is in place, we can still consider if it's big enough, right? We could use that as the biggest swap number. Maybe. In fact, okay, we can just put. But they all have to be equal to that number, though. So you can't just pick the biggest number, because then all the outplaced numbers would not be exactly k, right? Has to be one of the numbers. So it has to be from 1 to n. Well, the biggest number that has to participate. But can you use it to swap all the numbers though? This is definitely not a quick Q2. Even if I do get, or if I get it anyway. So we have to take the smallest number, right? At least. But then the smallest number can. How does this even work? Trying to think whether you can draw a graph on a 32 bits, like a equivalence class type thing. Man, I am not fast on this one. I don't want to cheat yet on the rankings in terms of like just looking at it, not like actual cheating. But was that because in theory people might not have gotten it yet, and also it doesn't help because I feel like a lot of people just cheat anyway. So the leaderboard doesn't really give a good indication of how many people solved this legitimately at minute 10. Okay, is there a swap principle? No, because there's no pockets, right? The reason why there are no pockets is because even the intermediate ones have to be exactly n. But then is it just like, I don't know. I don't know if this is true, but 1, 2, 0. I don't know. I'm gonna YOLO it. Can't prove it honestly, or like not actively, but I just couldn't find a counterexample. That's the TLDR. All right, Q3. Let's go. I don't know how I feel about that one. Okay. Optimal activation order. You have two arrays, value and limit, both length n. All elements are inactive. You activate element I. The number of currently active elements must be strictly less than limits of I. Number of, okay. So you have to do this in kind of an order, sort of. I did it. When you activate I, the total activation value. Okay. After each activation, the number of currently active elements become X. What's X? What's X? What's X? What? Did I miss something? Is total activation value X? Leetcode does not edited problems, turns out. If the number of current becomes X, then all elements. Or maybe I don't get it. Okay, so if the number of currently active elements become 5, then all elements J with limits of J is less than or equal to 5 becomes permanently inactive unit. Okay, I mean I guess that makes sense, but they shouldn't put it in like a variable X. Like they highlight it as a thing, so it's very confusing the notation. Okay, so activate 1. I mean in this case, if we 1, 2, 3 makes sense, right? 5 maybe. 5. It's just like a heap problem, this one, but feels like it anyway. It's just greedy on the heap. But what does it mean by permanently? Oh, so that means that limit is actually okay. I see. So because so you have more inactive elements, so then now active is smaller, so then you can maybe do more limits. It's a very awkward problem for sure. And it's big. I mean, this is just heap in any case, I think, unless I'm misreading this one. But, okay. The number of current active is it though? Maybe I'm wrong on this actually. And it becomes inactive, so then it's active. Okay. I mean, it is sorting, maybe not heap. And sorting would be based on an exchange principle. This one's a very awkward one, but I mean, these are good problems. I think they're like actual problems, maybe, even if the reading part is a little bit weird. That's the tricky part. But active after 1. Oh, but they become inactive. And because they become inactive, they cannot be activated. Okay. Is it greedy? this one maybe would take the 2. I mean, it is going to be some sort of greedy, but do you want to do greedy on active or? I mean, it feels like a sorting problem, but honestly, it's not. Or maybe a heap problem. How do you choose though? Sort by limit? You always want to sort by limit? No, I don't think so. Because you can have one that is, if you have something like limit 1, 1, and then you have like, I don't know, limit 4, 4, 4, 4, 4 limits, and then like, you know, 5, 5, 5, 5, then you would just want to do all 4 5s and just ignore this one, right? So how do we kind of get this? Because otherwise, if you do these 4, then this gets the inactive, and then you just get like 6, you don't get enough points, right? But then on the other hand, if you do something like 100, or no, let's just do 10, 10, 1. If you don't do it immediately, let's say you have 22, 10, 2 or something. This function is way weird, the active function. This seems like a problem that I'm going to get 5 wrong answers on. Because I'm going to use a greedy way, and I don't know how. Because here, well, I mean, even if you say 3, and I even say this is 15, you would, if you do greedy, you may do the 2 first, but then now this becomes inactive, and then you do this. But what you want to do is actually do this first, then this one, then this one, then you get all 3, right? There's this weird thing. This one I also don't know if I know, but maybe now it's okay to cheat on the timing. Oh, people got it fast. I mean, there are cheaters though, but some people, I mean, Limp Panda is most certainly not cheating, so that's pretty. Okay, so given the same limit, we definitely want to sort within the same limit, right? Then the question is, how do you do it? Oh, heap on the limit, huh? Heap on the limit, and then figure out how many you want to keep along the way. Okay, I mean, I guess. So then you sort by the limit, and then you just do it. Because then at the time you're at 2. Okay, so the reason is because when the limit is 2, you can only do. Also, I'm wrong on this one, because you would just do the 1 anyway, because it invalidates itself. So okay. So the ideal strategy is choose 1 from 1, 2 from 2, 3 from 3, and then so forth, and then sum that up. Okay. Okay, I see. It is a very weird problem, but okay. So then now we have 4 VL and zip value limit. Okay, yeah, that me constructing this example incorrectly kind of cost me some time, but that's okay. I don't think I really understood this problem anyway. I have to okay, resort, reverse true. Technically, you could use a k heap, but I think that's it, right? It's a really confusing looking problem, but I think that's fine. F k sub I. Is it 16.6? Oh, I mean, I guess that makes sense. $16,612. Yolo submit. Okay, that one, it's kind of hard to read, but I see. Next special palindrome number. It's a palindrome. Every digit k appears k times. Return the smallest special number strictly greater than n. I'm sorry, I'm not even focused. Okay, let's take a look. Palindrome, every digit k, and k times. So 2 appears twice. 3, what's 30? Oh, 30, what? What's 33? What's n? The smallest special number strictly. Oh, I see. Okay. So what does that mean? Palindrome, right? So 1 to 10 or 1 to 9 or 0 to 9 maybe. Whatever. I don't know if 0 is 1. But either way, okay. Then you have 11 to 99. But not, are they all special? No. In fact, only one special is 22. Actually, 0 to 9 is wrong too. I think 1 is the only one. I messed this up. You have 33, 4, 4, 4, 4, right? So that means that we have to build from these components. Oh, 10 to the 15. Right, so we have to just build the next number from these components, right? And I don't know how I'm running this, right? And that's it. There's no zeros, right? Okay. 33 is because, well, can we do it with 2 digits? Right? Nope. So then we do it with 3 digits. 3 digits either this or some combination of this. It has to be a palindrome. Oh, that's right, it's a palindrome. So you can't even combine, say, 1 and 33. So basically, only the even numbers matter. Well, and maybe 1 odd number. So that means that we have 4 even numbers that can be used as components. And then 1 odd number maybe. And it has to be in the middle. This anytime this palindrome is an annoying problem, but okay. I'm trying to think whether you can just brute force this in a way, but maybe not. There's a lot of digits, 15 digits at most, 15 factorial. I mean, it's not gonna be 15. It's only with 7 factorial, right? Because it's only half. 7 factorial. 5,000. So only 7 factorial things to try, and you get the rest, right? You just, well, it's 7 factorial. We have to, but I mean, 7 factorial is only 5,000. So, but that's given. It's not purely 7 factorial because there's a lot of dupes. but then now we have to choose. Okay, let's just YOLO it. I think it seems reasonable, but okay, so then maybe we try it for digits, right? So string n, d maybe for digits, either the length. Then now we try. We only have 9 numbers, right? So we try. The current digit to consider. So we only have 9 numbers. Current digit. And then maybe just like an array, I don't know, something like this, right? And the idea being that, okay, so if current d is greater than or equal to d, then we give it a try, right? We don't return necessary. Otherwise, we just put it in. I always forget which way is faster. Whether it, I mean, with 9 digits, maybe it's faster to just construct a thing, but like just running it like this, maybe. I never know. Okay, right. And then maybe we also do if current d is bigger than best d, then we just return, because that means that we have too many digits. Then we don't do, right? Yeah, because we have too many digits, we don't want to just branch it off. Okay, so then now we, I don't know, go to okay, right? I am dumb, but it's fine. Go, we try start at number 1. Current d, oh, we also want to do, obviously, if current is greater than equal to 10, then we just return. Technically that's after the current d, I think, actually. Okay, 1 0, just empty array, right? And then we just return best, maybe. Best is equal to infinity. And then now we give array a try. So it's just some permutation of this, right? All the numbers. Oh, I have to do the odd thing, right? So maybe I have to do the odd thing to filter it out, filter it down. Force, right? So if current mod 2 is equal to 1, maybe I just put it this way. Okay, so we current odd is equal to, maybe this should be cached, because otherwise you're doing a lot of mods, but it's okay. Let's just do n1, then slightly faster should be. Okay, so to current odd and it's not equal to odd, then we can do this. We add it only if that's true. Oh no, that's because they could be both false. So we want, okay, if current odd and not odd, if current odd, if not odd, no. Okay, so how does this work again? Yeah, let's just do, I'm dumb. Let's just do 0, right? Odds. If then odds increment by 1, or why am I so bad at this part? Okay. Okay, now we have the numbers, only one odd, some amount evens, so then now we brute force it, right? Just brute force the left side, so then now we have some numbers. Do I have, Leetcode has a permutation, right? Permutation, I forget. Leetcode.permutation, okay. And combinations. Okay, so how do I write it? Let's see. Right? The new way is way, and then basically what we're saying is that, what are we saying? We're saying that array sub I dot extend, we want to times I, right? Divided by 2. Yep. Those are the following digits. If there's an odd, then we have to figure it out. Alright. Yeah, okay. We'll figure it out. If there's an odd. Okay, fine. Like now, I suppose. Odd is equal to none. If O sub I dot 2 is equal to 1, then odd is equal to I. Then we have the number in the middle. Okay. So then now, what's it called? Iterator's dot permutations. Okay. Right. So for P and does it sort it? I know that in C++ that version is sorted. Okay, they'll be in sorted order. Okay, and the reason why is, yeah, so then we can terminate early, possibly, right? It should be sorted though. Everything should be sorted, so I don't need to sort again. But then now we want to say, yeah, we want to construct it to a number. So then now we just have oh, whoops. And then current, or if odd is not none, then odd. This is an X. So now, if the current number is greater than or equal to, is it greater than? Greater than, okay. It's greater than n, and current is less than best, then current is, or best is equal to current. I want to update it. Best D is equal to length of array times 2 plus 1 if odd is not none, else zeros. I hate using ternary digits, but also non-local best D, and then that's it. We don't have to return anything. Oh, we do want to terminate early, and if this is the case, then we can just return int number is not, put it in the way. 66 is definitely not right. Oh well. Okay, 1. No, that's actually right. This is not right there. 2. This should be 1, right? Am I using the wrong syntax? Let's try this real quick. No, I mean 2. Oh, I. Oh man. Okay. Silly. Okay. Now what did I get? 30 input 33. Okay, too much output, I guess. Should just let me know. 2 is 22. Oh, no 0. Why do I have 0? I have a 1. Why do I have a 0? Dun, dun, dun. Two, 1, 2. Oh, odd is a. Wait, no. Odd. Oh, I put odd as I again. Love it. Love it. All right, looks okay. I mean, I think the only thing left to do is to try a really big number, right? 10 to the 15 or something. So something like that, maybe. Decided that is too big. Might also time out. We might have to do this brute force in a different order, because this kind of maybe tries 2 big numbers first. So we do want to sort that. Okay, so is it good? I mean, not a great thing, but better that, you know, we have it now versus whatever. But I just want to make sure that this works all together, maybe. Or is it just always? I guess I have to get rid of this number first. Because it probably is worth. Yeah. I'm trying to, I do wonder if it is always possible to try for every digit. I mean, kind of like a DP kind of way, right? There are a lot of numbers. I thought there were fewer than. Maybe I'm just not doing them in order. How many numbers are there? How many possible numbers are there? I'm a little bit. I mean, it'll get out limited, but I want to get some idea. I mean, well, most of the code. I think we just have to do this reconstruction in an actual not stupid order, which we can maybe do. So is that an infinite loop? I don't think so, though. How about even something more sensible like that? How long did that take? Even 1 second for that is not great. I mean, of course, we're printing out a lot of stuff, but because yeah, even if you see the 6, 7, 8, 9, which is not great, but it tests the 13-digit numbers first for a 6-digit number, right? That's just silly. So we can maybe just I do a left and so it has to be at least that. No. Then now I guess we don't have to care about current D. Well, we do, but no, we just do left then. Yeah, let's just do left. Then now we can maybe do something like for I and j is equal to d, while true we do j yeah, if best is equal to infinity, we if it's not equal to infinity, then we break current d. Okay, no, that's also not needed anymore. Where's my odds thing? Didn't I have an odds thing? Oh no, I did it here instead. I changed it. I'm trying to figure it out. Okay. Current D again, what? Oh. This is just left minus current. Okay, this is much faster. Does it give me the answer though? I actually don't know if this is the right answer, but we can, and we're still printing stuff out to remember to remove stuff. And now we have, right. It's still too slow. Maybe. Oh, 4 seconds. I mean, it's not too fast, but I'm gonna be happy with it. How many digits is this? Because I'm trying to think. 15. This should be 16 digits, right? 15 digits. Maybe I tried a lot of 15-digit things. That's why it takes so long. Can I do better? Are there always 16 digits? Like, it's always just 15 or 16 digits, right? So then, I don't know, to be honest. I'm going to YOLO submit. I think this is good enough to YOLO submit as soon as I could find my print statement that I can remove. But I'm not super confident about it. I think we maybe have to do one more optimization. It seems like there should be, but maybe not. Ooh, that's even slower somehow. But still YOLO submit. May time out, honestly. Oh, well, ooh. I still have a print statement, by the way, so that's actually not great. But also, why is this so off? J is equal to D. Yeah, I still have a print statement, actually. I thought I removed, well, I did remove one. I guess this one's fine, actually, because it's only one per result. Well, I mean, it can improve, but it's fine. Okay, so this one is actually a good one to show us. Still need to remove this. Maybe a silly mistake. What happened here? 4. I mean, this is definitely an answer, but why is it at 8? It should be 4, right? 4. So 4. Did I mess up the numbers? I clearly did. There's 8 4s. 4 and a 4 means that yeah, this is actually just wrong, right? What did I do wrong? Because the input. No. Oh no, this is right. 4 and a 4. But why is best? Oh, why is current? P. So we extend 4 by 2. So this just this. So then it's this times this. But How did it mess up so much? Maybe that's why. What was the other one? Maybe that's why I messed up so much, but by numbers, because it's searching all these random things. 4 is just what? P, right? Let's look at P real quick. Yeah, I mean this looks right. Oh, I am dumb. Larry, what are you doing? That's why it takes so long. Oh, what a silly mistake. That's why it took so long for the code, because it just keeps on, it's doing crazy big nums. Actually. See? Yeah, Larry, you're dumb. Okay, where's my other print statement? I guess that's mostly it, really. Alright, silly mistake. Let's go. Come on, baby. Okay, so it was definitely just a silly mistake. Okay, I was like, it shouldn't time out, but couldn't figure out. And the reason why I timed out is because, yeah, this only gets the first permutation actually. So I got very lucky in a way, but also unlucky. Yeah, pretty okay. Probably should have done that one without the. I mean, I think the time I did was fine, but maybe a little bit too much debugging. But yeah, I mean, not really much else to say really. I mean, I think it's a pretty interesting problem. But yeah, let me actually put this in. Yeah. Let's do a quick retro, right? We did it actually pretty relatively quickly today. Let me get a water. I'll just finish the retro. What was Q1? Q1. I mean, this one was fine. Annoying to, not even that annoying, but I think I just we were about off by once. I think this is fine. This one just took a while to understand it. Oh, actually, I still don't know that I have the proof for this one. I mean, I think I have a proof, but it's not a good proof. I mean, I have an inkling. I don't think it's a good proof. So I don't know about this one. It's a little bit YOLO. How long did I spend on this one? 7 minutes? Yeah. This one, yeah, I think I just don't know how to read this correctly for a while. But once you do, then it's fine. Q4, I got very, I don't think there was anything too tricky about this one, the way that I did it. It's just that that was so dumb. I'm just curious whether this submission, or, oh, I guess I didn't have one. Because I had the one where it was just current D, right? Or whatever it is. I'm curious whether that would work. So let me, it's okay, it's fine. This is fast enough. I am curious whether that would have worked. But the reason is because it timed out when I tried to do it with this one. But I mean, this is definitely the better way to look into it anyway. And honestly, I didn't really prove this, but I think it either is D or D plus 1 anyway. So the other way that didn't really make sense. I think that's right. I could be wrong. And like we can probably just do the like we could probably given this just, yeah, I don't know, we probably could can write something to look at all the numbers, like the smallest. No, because so there's a okay, so we can even just think about this a little bit, right? We have 1, we have 2 digits, 3, 4, 5. Oh, so yeah, up to 9 digits we have all the numbers possible, right? In the sense that there's at least one special palindrome of every digit. And then there's one for 10, 11, 12, 13, 14, 15, right? Just all these plus 9. So definitely there's a special palindrome for every number of digits. So, or at least every number of digits up to 15, as this case is, or 16 or whatever. So I think that's pretty fine. Yeah, I didn't need to do it. I mean, the other way maybe would have been okay, but it's still, this made a lot of sense. It's just a silly mistake on my part. I mean, it was, yeah. I mean, that was also why it was taking so long, because it keeps on shifting and adding. So when permutation is pretty big, it just kind of keeps on extending forever and ever and ever. Though it is weird though, because if it's 4-4, oh, it's permutations. So actually, I made a mistake here. This could be optimized a little bit. I forget what it's combinations maybe. But we, I mean, the way that I did it is actually wrong, is what I'm trying to say. I mean, given the max of 7 factorial is fine, but it actually dupes, right? Because it should not actually, now that I think about it, it should not have gone, I don't know how long it took. Okay, did you show me? I mean, this is actually still pretty fast, but it's actually a little bit inaccurate because Yeah, it did 4-4 twice, which is why it had that weird number. Which is kind of, it turned out good for me in the sense that other test cases may have been tougher to debug, but it still actually is wrong, right? Because you don't want to do 4-4 twice. Like you don't want, like you want a combination, or you want a permutation that's not unique, right? For example, maybe we just wrote something real quick, like for p in iter2s dot permutations of, I don't know, 1 1 1 1 1, then, you know, print p, and this should, like, ideally this should print once, right? But instead it prints 5 factorial times, which is 120 times, which is not what you want. What is the actually, I don't know if there's a combination. I guess combinations is right, maybe. Oh no, combination is unique on their position, not their value. Python permutations unique, right? I mean, we could have done it. Like, we could write it ourselves, but that's actually I mean, I'm trying to figure out, like, like for this problem, it didn't bite us, right? But like for this problem, it didn't bite us, right? But it definitely could have been. And I mean, I guess I would have just written my own, but this is still like very silly. I mean, this made it a lot easier to finish, but it's still not great actually. Anyway, I mean, I'll go over all in my videos, but yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.